Some of the conversations that we've had on this podcast have focused on new research into discovering and treating disease earlier, which improves chances for a cure. But what if there was a way to not just discover a disease before it was noticeable, but also predict that you'd get sick before you even had symptoms? In the future, it's possible the very nature of what being sick means will be called into question. We'll talk with thought leaders in medical research about the technology that's driving this forward. That's ahead on this episode of Tomorrow's Cure, a podcast from Mayo Clinic that brings the future of medicine to the present. I'm Kathy Wurzer. Thanks for being with us. Today, we're speaking with three experts who are bringing medical research into the future and hopefully making cancer a thing of the past. Dr. Vijay Shah is Executive Dean of Research at Mayo Clinic. He's a gastroenterologist and a hepatologist. That's a liver disease expert. His own research focuses on chronic liver disease, but as the Executive Dean of Research, his daily work is to help Mayo Clinic researchers pursue innovation. Dr. Shah works with Heidi Dieter, the Chief Research Officer at Mayo Clinic. She is responsible for all research activities across Mayo Clinic as a whole. They describe themselves as yin and yang. Dr. Shah does the science, Heidi translates it so everyone can understand. Also joining us today is Dwight Dierks. He's the Senior Vice President of Software Engineering at technology company and computer chip maker NVIDIA, a California-based firm that is a leading supplier of artificial intelligence hardware and software. Dwight and his wife, Diane, have made a significant gift to Mayo Clinic to advance the use of artificial intelligence in the early detection and treatment of cancer and to support the Mayo Clinic platform. It's so nice to have you all with us. Thank you for taking the time. I appreciate it.
Thank you.
It's a pleasure, Kathy.
Thanks for having us.
Thank you so much. Let's start with the question, Dr. Shah, that I raised in the introduction, if we could. If we could prevent patients from ever becoming patients in the first place, I mean, that's a pretty provocative statement, right? And I would think that would mean that medicine moves from what I would call a remedial sick care model to a new healthcare paradigm. So because you're working with teams of researchers, what does that new model look like right now?
Kathy, you're describing the Holy Grail, which is the ability to avoid a disease or prevent a disease before it even happens. So we have some challenges with that currently, which is that we use guidelines. And the problem with guidelines is they treat everybody the same. And in fact, all of us are different, and we have different risks for different types of diseases. Now, in the past, part of the reason that we had these guidelines that affected everybody is that we didn't have the technologies that we have today. The technologies today allow us to integrate multi-omics, which is all of your gene profile, your RNA profile, your protein profiles, and integrate that importantly with the exposures that you have every day, your environment. And we each have a different environment exposure and pattern each day, depending what we eat, what we see, what we hear, where we live, our upbringings. And that's why it's been so hard to predict disease, because we have not, till this day, been able to truly integrate all of these different types of environmental and genetic factors to make a personalized prediction for one's health.
Wow. Dr. Shah, we're talking about a lot of data here. And Dwight, I'm going to bring you into the conversation because I know as a person who's worked in the computer industry, when you hear what Dr. Shah is talking about, again, vast oceans of data, I'm betting artificial intelligence probably plays a big role in collating that data. Am I right?
That's exactly right. With artificial intelligence, you get to automate the collection, the analysis, the usefulness of that data and how to apply use cases. It's exactly what artificial intelligence was designed to do.
Heidi, how is AI and machine learning contributing to moving some of the science forward?
I would say a couple things. So when I think about the 30 years that I've been in healthcare from the business side and looking at really sick patients and how we care for them and the process of how we care for them and the time that we spend with them, the time that they take out of their lives to come to see us and check on us, I think about there's got to be a better way to do this. And the diagnoses that we would have received 5 years ago, 10 years ago, is very different today, like the options that we have to treat that. And so when I hear Dr. Shah talking about the future and I hear Dwight talking about all that we can do using AI and the advancements that we've made, even in the last year or 2 years, put all of that together and you think there's got to be a better way to care for people and ideally care for people before they even need the care. And that's what we're trying to do as part of the Mayo Clinic strategy for research is how do we reach patients before they need serious and complex care?
Dr. Shaw, we're analyzing a patient's DNA to diagnose and treat diseases, right? And using drugs that are personalized down to the molecular level. But I'm wondering here about the progress made in looking at the environmental factors. Where are we on that?
Kathy, what we're describing here is pre-cure. It's the ability to cure a disease before it happens. And as you said, we've made tremendous advances in sequencing, and we have lots of molecular information on so many patients. However, we know that that still hasn't allowed us to prevent serious and complex disease in most individuals. So, our environmental record right now is not actionable enough to really help us prevent disease. So, for example, right now, our environmental record may consist of some sort of a survey that you fill out. It may consist of a blood test that doesn't occur just in time because it will be a specialized lab that may measure the amount of mercury in your blood. It may measure a variety of different things. So, what Precure is aspiring to do and is doing is identify what type of markers organs may have that can allow us to assess their level of health, their health span, based on the types of exposures that that organ may have been exposed to. The other part that we're looking at is what we call the ledger of the human experience. And by that, what I mean is what are the exposures you've had? How do we compile them and digitize them? So this is where our technology becomes our asset, right? Because instead of having all kinds of physical things like blood tests, et cetera, how do we use the digitization of data and compile it? Just send it right back to the healthcare team instantaneously in what I call a closed loop. So the closed loop is all of that data coming back to the patient, coming back to the care team, and leading to an action. It might be a recommendation that you probably shouldn't keep walking the way you walk to work right now because you're getting exposed to certain environmental toxins when you're going that way, and pick a different route. So that's a very simple example of how a closed loop of data coming from the patient to the care team and back in an automated way to the patient could lead to adjustments in their environmental exposures.
I want to put a pin in this for just a moment because I want to bring Dwight into this and maybe put a face on what we're talking about. Specifically, your sister Heidi lived with cancer for quite some time before she died, but it was really tough. So, could you please tell us about her journey, if you would, if you're comfortable?
Sure. There's three words that no one ever wants to hear from your doctor, which is you have cancer. And when you have cancer, you typically want to know two things. How long have I had it? And what are we going to do about it? With AI, like what Dr. Shaw was saying, there's all these events in your life, and there's so much data that could be coming out of that. If you could run that real time, the moment something happens that changes in your body, you can detect that cancer is starting, and you can start working on the cure. And then when the cure comes, again, as Dr. Shaw said, we used to treat this all in one homogeneous way. Whereas everybody is different, every cancer type is different and unique in each individual. So figuring out how to apply a cure needs to be different going forward, and it can be with the tools that AI brings to doctors. And so those two things is what led us to this journey about, how can we apply AI to what would have brought her, peace of mind, which is knowing that as soon as it was detected, treatment could be started, and then the treatments could be personalized and right sized and brought to her in a timely fashion. But I think there is a lot of on her side a lot of concern that maybe it could have been detected earlier through an earlier scan, but was missed. And in the end, I think by the time that everything was detected, it was maybe a little bit too late. It was stage 4, and it had spread, and so treatment was applied, but it was about as good as could be done, I guess, with the circumstances.
I understand. I'm so sorry. Heidi, when you hear Dwight's story about his sister, what goes through your mind?
Yeah, well, first of all, I would say I'm horribly sorry. What a very sad situation. And unfortunately, Dwight and I are in the same club that neither of us chose to be part of. So I lost my mom to cancer, my best friend, right? I just miss her every day, even though it's been 6 years. And I would say some of the same things, like why didn't we know about it before it was stage 4? And what tools could we have access to today that we didn't back then, 21 years ago when she was first diagnosed, that would prevent someone else from having to go through that same horrific journey. It's why I'm so grateful for people like Dwight who understand AI and know how to use the tools. And so we just need to get data in his hands, and people like Dr. Shaw who are doing science every day and utilizing AI in their labs that can allow us to accelerate the time it takes from discovery to getting treatments directly to a patient.
So let me ask you about this. And Dwight, chime in, and Dr. Shaw. So AI can take this ocean of information that we're talking about, genetic, environmental factors as well. It can take all that information and find patterns and make predictions, right? So are we talking about creating models or simulations for each patient or something else?
One of the models that we use in healthcare that's evolving now is called the digital twin. And the digital twin is a simulation of one's potential outcomes. So that digital twin requires a great deal of data that's integrated into an algorithm for that individual and their data. And it also requires a large amount of other individuals' data that is integrated as well, so that you can take your data, compare it to all the different other people, and then create those simulations. And of course, your personal exposures, as we talked about, and your environmental exposures play a key role in those simulations of what are potential outcomes for you.
Say, Dwight, aren't digital twins used in engineering?
Yeah, I mean, digital twins are being really at the forefront of modernizing manufacturing, as Dr. Shaw said, modernizing healthcare. But in the future, we'll probably be able to create a digital twin of each individual that comes into Mayo and then apply thousands of different cures in the computer in digital space overnight and allow the doctors to figure out what's the best way to treat the patient. We're not quite there yet today, but we're certainly along that path. And then, as Dr. Shaw said, comparing that to other patients and other scenarios, you can probably come up with all kinds of individualized care opportunities, which makes a ton of sense. And you could time speed up the potential applications and see how it looks in the morning or the next day or however long it takes to compute. And then the right care plan could be created for that individual.
Dr. Shaw, I'm wondering here, this seems again like it could be a little overwhelming for some people. I mean, that's a lot of data, right? And maybe scary. And I wonder for folks who are not really very literate when it comes to health information, might this be a problem perhaps for some people?
Well, Kathy, I think it is scary and it's an opportunity. It's actually scary for care team members as well. And we know that even currently, with the amount of data that's coming in for care team members, they're overwhelmed. And our current electronic health record models provide lots of data already, but they don't provide them in a simulated way that is actionable for care delivery. And that's where the digital twin can help us simplify, at least in concept, if we design it right and modify our care models accordingly so that we use automation appropriately and we simplify the models so that it's not just giving lots of data, but it's giving a recommendation. That's the key, is people are looking for clinical decision support. And for the patient side, you're correct. Too much information is not always good. If you go and you want to buy something from the store, you want maybe 3 choices. But if you got 30 choices, that's too much. And so patients as well need a way that the information is provided to them in a simple way that lets them make a simple decision. Do I want to drink this beer or not? What is my liver status right now? Simple decisions that help them make important decisions every day in their life.
And do you see this as being a good tool, say, to predict potential issues?
Well, I'll give you an example, Kathy. When you're exercising, are you overdoing it on your joint, or is your joint doing just fine? What we need is some sort of a joint sensor that can convey the information of how much stiffness is in the tendon in your joint. Now, this is actually not that far-fetched. We can measure the stiffness in your tendon very easily. It's just a matter of having a sensor that can convey that information to you or to your care team member over a period of time to allow you to make an actionable decision, like get off the stair stepper.
Yeah, I was thinking about the expectations that I have outside of my day job and just my general way of living. And there's so much access at our fingertips, and my expectations increase every day because I have new tools that are available to help me manage my life, track my children, track the grocery list, etc. And we need to have that in healthcare as well. I want to know the information. I don't want to be bombarded by the information. So I want it to come to me when I need to know it. The rest of the time, I don't want to have to worry about it. So if it can be fed to me, Heidi, it's time to go in for a mammogram. I would much rather have that than to take time out of my life to schedule it once a year, to go in, to wait, to go through the actual procedure itself, to be nervous for 24 hours, waiting for the results to come back, when I might not need to ever worry about that. If we can simplify how we care for people preventatively and again, intercept when they do need it, isn't that really what we all want from a healthcare system?
So, really, we're talking about empowering patients to a degree we've never really seen before. Would that be correct?
Yeah, exactly. I think the more that you put the data in front of the patients have the ability to affect the change because they're the ones that are going to be making the decisions out in the world that is going to cause positive or negative things to happen in this regard. So putting that data out there for the patients to see, the benefit will be exactly that.
Dr. Shaw, I want to ask one more question about digital twin because I think it's a very interesting concept, and I wonder if you have an answer to this about who owns and controls the data that's collected from people. In a sense, who would own your digital twin?
The ideal place for this to live is in your phone, in your own phone or your place that you want to keep it. And so I'll give you a very benign example. I like to follow the New York Mets. And so I'm going to work with my sports app and let it collect information about me. It's going to know I like the Mets and it's going to give me the Mets score. Now, if you take that to healthcare, if you want to know about the status of your tendon, you're probably going to have to share that information and you'll get the value exchange, which is going to make recommendations to you for your healthcare.
Heidi, it seems like this is a huge paradigm change, because I think a lot of patients rely on their physicians to make the decisions for them. Does that make sense?
Yeah, totally agree. But I do think it's a shift in how people are thinking based on how we're living our lives currently and what we're utilizing. And Dr. Shaw gave the Med score example. So it's the perfect way to think about it. If you want to be actively engaged in your healthcare, of course, you will use the similar scenario of a sports app. You will use a health app that will help you manage your own healthcare. If you want to have it completely in the hands of the physician and you really don't want to be engaged at all, of course, that would be an option too. This access to data has to be done in a way that protects patients. And so Mayo Clinic has created what we call Mayo Clinic Platform that allows what we call data under glass so that the data is protected and it is not sold, it is not shared, but it allows our scientists to use all of the data to gather new insights into disease and into potential discoveries or cures for patients. And I see that continuing to grow and just be a resource for the rest of the country in terms of access to data and understanding what a patient's trajectory might be. But again, it has to be very protected to ensure that patients' data is not shared externally. But Dr. Shaw, do you want to share a little bit more scientifically
Yeah.
about how platform works?
Well, Heidi, you summarized it very well. What I will add is that both Dwight and Heidi described healthcare challenges in part due to a pipeline model of healthcare. And that is our current model of healthcare. One identifies that they have some symptoms, they go to the doctor, and they go through a variety of clinics, a variety of potentially health systems, get recommendations, and then follow those. So the problem with that model is it's not scalable because for every patient, such as Heidi or Dwight's family member who might have been able to come to Mayo Clinic, we have hundreds of thousands of patients who want to come to Mayo Clinic across the world, but they can't come to Mayo Clinic for a variety of reasons. So what's a new model where we can use our Mayo Clinic model of care. We can use the data that we have generated through all of the care that we've provided for all of the time Mayo Clinic's been in existence, and provide insights, recommendations based on all of that data. And of course, a platform becomes powerful when there's lots of users of the platform and lots of providers in the platform. And that's why the Mayo Clinic platform has a variety of programs that bring in startup companies that can generate those algorithms that Dwight talked about. And then it has lots of health systems that also work with us to coordinate data and generate new algorithms that in turn can help patients around the world.
Dwight, you're very familiar with this. What excites you about this potential?
The Mayo Clinic platform is so exciting because without the data platform being there, you don't have the ability to do all the things Dr. Shah talked about. Some patients don't want to be that involved, and some do. And so for those that don't want to be that involved, by having the Mayo data platform, it allows other companies to create applications that could alert users, you might be in jeopardy of this, something like that, because the data is now there. It's without it, you have no foundation to build all these great things that AI could help assist doctors with. Mayo has been really innovative and leading in this area, and without it, none of this is really possible.
How do you lead teams into places that haven't even been imagined yet? What map do you use?
I would think in general, you basically put a broad challenge out there, something that you want to solve, a problem statement that you want to solve, and then you put smart people in good places to figure out solutions that could be done, and then you have to go prove it. And then once you prove it, you pour gasoline and accelerate it.
And what's the gasoline? Just curious.
Either more resources, more computing, ability to go get things done. But first, you have to show that it's possible. Because, like you said, some of these things haven't yet been done before.
Dr. Shah?
Kathy, it's a great question to ask Dwight, who is at NVIDIA, super innovative company, and to ask Heidi and myself, who are at Mayo Clinic, another super innovative company. And each company has a different culture. And yet, both cultures lead to innovation. And so I'll give you the example at Mayo Clinic. Some aspects are very similar to what Dwight said. Heidi and I try to set a powerful vision. What could things be like? And that vision does not have to be achievable anytime in the near future. It could be an aspiration, it could be an inspiration, and it's a journey. And so once we've set that vision and gotten the folks excited, as Dwight said, we recognize that each individual within Mayo Clinic is going to contribute to innovation in a different way. And so we try to seed a culture of innovation. And some of them may be the big thinkers, and then others are going to be skeptics. Others are going to challenge us. And we need all of that. To do proper innovation, we need diversity of thought. We need everybody in once we make a decision. But we also need to recognize that some people will come with big ideas. Other people are going to test the ideas. Others are going to be implementers. But we innovate better together when we have a diversity of thought and ideas and people.
Yeah, I think Dr. Shah stated it very well. We are a culture of innovation at Mayo Clinic, and it is fostered at every level. It's all 82,000 employees are expected to be innovating every day. And that's what we see, and we're very grateful for that. So in terms of how do you lead, I would say it's similar to what Dwight and Dr. Shah said. You empower them. You give them access to tools and the technology, and then you get out of their way and allow them to do what it is that they want to do. You make it easy for them, not burdensome.
Dwight, you're in a field that is dynamic, obviously, and you're used to pushing the boundaries of what's possible, right? But as you know, sometimes progress can be slow. And when you're talking about situations like your sister's cancer journey, it can be frustrating to watch when you're seeing what's in the healthcare industry right now. So, what is the spark that's keeping you actively involved in this particular interest of yours in terms of helping Mayo Clinic?
In terms of what's the spark for myself is knowing that all the technology that we built at NVIDIA can be applied to improving healthcare, both in prevention, in drug discoveries, in cures, in personalized cures. It means that what we do at NVIDIA can be applied to all of our closest family and friends, and so in terms of the spark that keeps me going. It's great knowing that, the smart people at Mayo Clinic know how to leverage the AI technologies that we created and can go make these broad dreams, these broad problem statements, become realities. And so that's really was the impetus behind our donation to Mayo Clinic and why we're so excited about what they're doing with it.
If your sister Heidi were still here, Dwight, what do you think she'd say about your efforts, what you're doing?
I think she'd probably be really happy that the challenges she went through are going to help the future challenges of people that come after her.
There's a classic innovation theory that suggests that paradigm-shifting inventions typically follow an S-curve. The uptake of an innovation is usually kind of slow, and then it reaches an inflection point. So I'm curious, Heidi, where are we on the S-curve of what we're talking about?
Oh gosh, that's a great question. I would say in terms of the data and the AI that we're using is light years today, different than what we knew 6 months ago. It is iterating so rapidly, it's hard to keep up with it. And so when we talk about the 17 years it takes to go from a discovery in a lab to a treatment for a patient, and that 17-year curve has not changed in decades, data and AI is going to rapidly accelerate it. In the lifetime of my children, who are 20 and 23, cures will be happening exponentially because we have access to tools and data that we didn't even 6 months ago or probably 4 weeks ago. It's just changing that quickly.
Dwight, that boggles my mind, truly. The speed is just amazing. Are you seeing that in your side of the ledger?
Oh, very much so. I mean, we talked about digital twins. Instead of, doing tests on real patients, for example, and measuring their results, trials could be done, on a supercomputer with many, hundreds of thousands of different outcomes done virtually, as opposed to, waiting for the lab environments.
Dr. Shaw, what do you think?
There is this term, the valley of disillusionment, and that occurs when a technology is hyped, and then we don't see the benefits of that technology. And I would say AI, I'll give you an example, because we were in this valley of disillusionment, and it's still a big challenge in terms of physicians and care team members and the challenges they have as a team, especially during COVID, a lot of burnout and still a lot of data management issues. And I remember talking about what kind of tools could really help us improve the way that we care for patients. And we talked a lot about voice and voice tools that could automatically generate notes from just your conversation with a patient. And that seemed kind of pie in the sky. But yet, within a year, we've implemented that into our practice. So that's an example of a technology that seems futuristic to just have a voice recording turn into actual documentation and assessments and recommendations. And it's just going so fast, and it's helping our care teams. There will be sectors that will be fast moving. Some will be slower. I think healthcare might be slower. It might be appropriate because lives are at stake. We don't want to break things, but it also has the biggest opportunities. So I like to say the biggest risk we can take sometimes, or the biggest risk, is not going fast enough.
Interesting conversation. I so appreciate your time. Thank you so much.
Thank you, Kathy. And thank you, Dwight.
Thank you, Dr. Shaw, and thank you, Heidi.
Thank you.
Tomorrow's Cure is a co-production of Mayo Clinic and PRX. Our producers are Deborah Balthazar and David Newtown. The show is edited by Genevieve Sponsler. Our sound engineer is Tommy Bazarian. Our theme was composed and produced by Terrence Bernardo. Tony Carlson is our production manager, and our executive producer is Jocelyn Gonzalez. The Mayo Clinic production team includes Hui Hong Ang, Margaret Shepard, Samantha Clarkson, Kara Mangold, Felipe Sosa, Kim Ona, and Bryn Sankey. Special thanks to Preston Spire for audiovisual production support. Be sure to follow Tomorrow's Cure wherever you get your podcasts. I'm your host, Kathy Wurzer. Thank you so much for listening.